Yes, so very good morning to everyone. Today in this session, let us see the very important theorem that we find in class 9, midpoint theorem, or it is also popularly known as MPT theorem. Let us see the statement of the theorem now. So in a rough way, see, uh, if I draw a triangle, let me call it as ABC, then the line joining the line joining the midpoints of any two sides of a triangle, midpoints of any two sides, you can choose any two sides of a triangle. Let me choose these two sides, AB and side AB and side AC. If you connect their midpoints, then this, let us call this DE. If you connect the midpoint means D is a midpoint of AB, E is a midpoint of AC. Now what happens if you connect the midpoints of any two sides of a triangle? Then obviously this is going to be third side. So this line will be parallel to DE, will be parallel to BC. DE will be parallel to BC, and same time DE will be half of BC, third side. Okay, so now let us prove this one. So let me write down the statement. The line joining the midpoints of any two sides of a triangle is parallel to the third side and half of it. Now let us see what they have given. Statement given. What is the given thing here? So here they have given ABC is a triangle. ABC is a triangle, and let us take this as E. Let me take it as a D, and this is E. D is the midpoint of AB. E is the midpoint of AC. That is D midpoint of AB, E midpoint of AC. Now, now, what to prove? This is the given thing. To prove, according to the statement, what we need to prove here? We need to prove that DE is DE is parallel to BC. First. Second thing, we need to prove DE is half of BC. So these are the two things we need to prove. One is DE is parallel to BC, and another one, DE is half of BC. Now let us try to prove this. How? Proof. Here let me draw a triangle. Let us name it as A, B and C, and D is a midpoint of AB, E is a midpoint of AC, and let us join DE. Now proof. Here we have some constructions. What is that construction? Extend DE up to DE up to F such that DE is equals to EF. See, already here there was a DE, and we will extend DE up to EF so that DE, the length of DE is equal to length of EF. Now join FC. This is small construction we need to follow here to prove that DE is parallel to BC and DE is half of BC. Now what you can see here in this triangle? In this triangle we can see that angle DEA is equals to angle CEF. These two angles are equal. Why? Vertically opposite angle. Let us consider these two triangles now. Let us prove them as a congruent triangles. See, so one thing, and second thing, we know that AE is equals to EC because E is a midpoint of AC, and one more, DE is equals to EF because by construction we already did it. DE is equals to EF. Now considering triangle ADE and triangle FEC. So in this triangle, what we can see here, let me give this as angle 1 and angle 2. Angle 1 is equals to angle 2. Angle 1 is equals to angle 2. Why? Because vertically opposite angles. Second one, AE is equals to AC because E is a midpoint of AC. And third one, DE is equals to EF. DE is equals to EF. This is because E by construction. This we have done it by construction. Correct? Now, from this to 1, 2 and 3 we can conclude that triangle AD triangle ADE is congruent to triangle FEC. This is by SAS congruency rule. SAS congruency rule because two sides and one an included angle is equal. So now therefore we can say that now we proved that these two triangles are congruent. By this one we can say that what we can say is we can prove that angle these two are equal. These two angles are equal. Why? Angle called let me 3 and 4. Angle 3 is equals to 4 because it is by CPCT. CPCT. Now therefore what we can say is, so you can see here this is AB, AC and CF. So these two triangles are equal. If these two triangles are equal, lines must be parallel. Converse of alternate interior angle axiom, we can say. Converse of alternate interior angles, which implies AB is parallel to FC. This is by because converse of alternate interior angle axiom. Okay. Now Therefore, if AB is parallel to FC, so AB is parallel to FC, then BD must be parallel to FC. BD, BD, C. FC is parallel to AB, then FC is also parallel to BD. So therefore, BD is parallel to FC. Now, this is one thing. Now what we can say, we already know that FC is equals to AD. Why? FC is equals to AD because CPCT. But it is given that FC is equal to AD, but AD is equals to BD. This is given. So this from 1 and 2 what we can say is, from 1 and 2, FC is equals to AD and AD is equal to BD. Therefore, these two must be equal. Therefore, FC is equals to BD. FC is equal to BD. And here we proved, let us call this as equation number A, equation number B. From A and B, what we can say? From A and B, quadrilateral DBFC is a parallelogram. So this is parallelogram. Therefore, we can say that what we can finally say, DBF. What is that? DB. Sorry, CF. DBCF. 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 This is a parallelogram. Therefore, finally we can say that DF is parallel to BC, which implies DE is also parallel to BC. Secondly, we know that DF is equals to BC. DF can be written as DE plus EF is equal to BC. This can be written as DE is equals to EF. Therefore, I can write it as, which is implies 2 times of DE is equals to BC, and therefore DE is equals to half of this one. Half comes here, half of BC. So therefore, we concluded. So we proved the required things. DE is parallel to BC and DE is half of BC. So this is one of the important theorem that we find in class 9th textbook. Okay, thank you so much.